Hello ladies and gentlemen, in this video I'm going to be explaining notes 1 and notes 2 with a handout that has all of the scientists' pictures and their names and what they discovered. And then we're also going to be comparing and contrasting atoms, ions, and isotopes. So let's start with our models. We have 5 different scientists we looked at in class, and we looked at how the model of their atom changed over time. The first scientist that we looked at was John Dalton. And John Dalton, he really had 5 postulates. So these 5 ideas of what the atom was and what it looked like. And one of the main ones that we kind of focus on is that he said that atoms are indivisible, meaning they can't be broken down. And later on, we did see that atoms can actually be broken down because we have particles that are in our atoms. But this is what he first said, and so that's kind of what we remember John Dalton by in terms of his 5 postulates. Now, J.J. Thomson, he was the next scientist, and he did use the cathode ray tube experiment. And when he did that, he discovered that there were these negative particles in the atom. He found that the negative particles were attracted to the positive end of a metal rod that he used for his experiment. So we were able to build on this prior example of what the model looked like. We are now adding a negative particle. Now notice there's no nucleus. That didn't come about yet. He knows that this sphere, he's saying, is positive. Okay, so that's what that picture is showing. So the sphere is positive, and we have these negative electrons. He's also known as the chocolate chip cookie model or the plum pudding model. That's what we know JJ for. Okay, after J.J. Thomson came Ernest Rutherford. And then Ernest Rutherford, he did the famous gold foil experiment. When he did the gold foil experiment, he discovered that most of those alpha particles were going straight through, but some of them actually did bounce back. So he discovered the nucleus. So what Ernest Rutherford stated is that we have a nucleus and that the atom is mostly empty space. Okay, so that's Ernest Rutherford. After Ernest Rutherford came Niels Bohr. Now, if we look at Niels Bohr, it looks similar to Ernest, except now we've added these orbits or orbitals. So this is where we say that electrons can jump to higher energy levels. So they're not just around the nucleus, they're in these specific locations or orbitals that all go with amount of energy. So if we have electrons in the first energy level, they can jump out further to areas that we would say would be like in the 3rd or 4th energy levels. And then our last model is Heisenberg, where he used quantum mechanics to develop this model, where he's saying that really electrons are not in these specific orbitals, but rather they're somewhere out there in the cloud. So he came up with the uncertainty principle, which states that it's impossible to know the speed and position of an electron. Okay, so that was notes 1. Now let's go ahead and review notes 2. So this is where we are comparing and contrasting atoms, ions, and isotopes. So I just picked a random element. I picked fluorine. So if I find fluorine on the periodic table, it's right here. Now notice the way that it's written on the periodic table. It has the atomic number at the top, and it has the atomic mass at the bottom. Now when we have it in notation, will actually have the mass number at the top and the atomic number at the bottom. So let's review what the atomic number tells us. The atomic number tells you your number of protons and your number of electrons. Your mass is equal to your number of protons plus your number of neutrons. So in order to find your number of neutrons, you need to take your mass and subtract it from your number of protons, which is the same thing as your atomic number. Okay, you have to know how to figure out your number of protons, neutrons, and electrons for an atom, ion, and isotope. So let's look at this first example in an atom. So in an atom, my number of protons is going to be equal to my atomic number. So it's going to be 9. Now I've stated this over and over again in class that protons never change. So even when I have a fluorine ion, my proton number is still going to be 9. Same thing with my isotope. It's still going to be 9 because your proton number is your atomic number, and that is the identity of the element. Now to figure out your electrons, in an atom, we know that an atom is neutral, meaning it doesn't have a charge. So my number of electrons is going to be equal to my number of protons. To figure out my neutrons, I have to take my mass and subtract it from my protons. So I'm going to take 19 and I'm going to subtract it from 9, and that's going to give me 10. Now moving on to an ion, that's when an atom loses or gains electrons. So if we have a negative ion, that means it is gaining electrons. If we have a positive ion, that means it is losing electrons. Okay? So here we have a negative ion. So my atom would have started with 9, but because it's more negative, that means I'm going to gain 1 electron. So I'm going to add 1. That means I have a total of 10 electrons. To figure out my neutrons, I'm going to take my mass, which has not changed, and I'm going to subtract it from my atomic number or proton number, and that's going to give me 10. So the only thing that changes when you go from an atom to an ion is your number of electrons. Now we're going to look at an isotope. In an isotope, this is an atom of the same element with a different number of neutrons. So what changes is the mass. The way we indicate the mass is with isotope notation. So this does not say fluorine minus 20, this says fluorine dash 20. 20 is my mass. I'm going to come down here. Now my electrons is still going to be 9. There is no negative or plus by my fluorine. These are equal to each other, just like they were in my atom. And then to figure out my neutrons, I am not going to take the average atomic mass that's right there. Instead, I'm going to take the mass that is in my notation, which is 20, and I'm going to subtract that from 9, and that's going to give me 11. So in an isotope, it's your number of neutrons that changes. Okay, now the last thing we're going to do is we're going to just briefly review the structure of your atom. So the center of your atom is called your nucleus. And then on the outside of your atom, we have our electrons. And then inside our nucleus, we have our neutrons that have no charge, and we have our positive protons. And we know that the electrons are located in our orbitals, or we can call those energy levels. Okay, and remember that your nucleus is where all of your mass is. That's why it's the neutrons and protons that have mass, not your electrons. Okay, thank you, ladies and gentlemen. Hopefully you can review that so you feel prepared for notes 1 and notes 2.